Alright, in this video we are going to do a goto. We're not going to do that. Just a few examples with goto. Alright, goto is not something you should use, but I just want to do a few examples because so why? Because this is more like assembly language, which is almost machine language, which is what CPUs actually do. Okay. So just to see a few examples so that if you look at assembly language, maybe this will help. Alright, so I'm going to start with is hello.c. Alright, and this is saying hello 3 times with a for loop. This is how most of you are used to thinking. So we call it with a parameter, there's 3, it goes into n. We start at 0, we go while we're less than n. We inside print hello. Alright, so 3 parts of a for loop. You have your initialization. We do that. We have your condition to check and increment. And then we have stuff that we do. Alright, so those are the parts of a for loop. Now I want to show how this would be done with goto, which is more or less how it actually gets converted into assembly language. So I will take this and put it up here. Let's see, why don't we just leave that? Okay, we'll leave that and we'll do another copy. We'll call this say hello to, and when we're done we can run it to make sure it actually does that. Okay, so what goto does is you have a label and it just jumps in the program, but you tell it where to jump. So I'll say do again. So the way you give a label is you have like a variable name with a colon on its own line is the tradition, and it's traditionally done with capital letters just to make it stand out. Alright, so what I want to do is break apart this for loop. And so do again sounds like something that should be the do something. The initialization would happen before we do any repeating. So the part that's after the do again is the part that's going to be repeated. Let me just pause for a second. Okay, I'm going to do a couple different. So do again is there. Let's see, I will put all of these in comments, except for this one. So we have our initialization, we have our condition to check. So the condition to check is always going to happen inside, and I'll have a done label as well. Okay, so our condition is going to be the same. So if I is less than n, then we continue. So if I is not less than n, then we will be done, and we'll go to done. Okay, so we're going to skip whatever else happens here. Condition to check, there it is. And when I put numbers on here, so initialization, condition to check, increment change, so this really happens fourth, and do something. Alright, so initialization, we go ahead and take care of that as well. So there's 0. We have our initialization. That only happens once. Then we do our condition to check. That happens second. third, we're supposed to have our do something, so we'll go ahead and have our do something. There's 3. Then the next thing should be the increment. That is the I++. Okay, the way a for loop works is you first do the initialization, you check the condition. If the condition is true, you do this. Then you do the increment, you check the condition again, you do this, you do the increment, you check the condition again. So if I'm right here where I did the increment in a for loop, the next thing that happens is check the condition. I'm going to go to there again, so I can go to do again. Okay, so this is basically what a for loop is doing for you. It takes the 3 statements and the body of the loop and basically does this. In assembly language, but the structure of it will look pretty much like this. There's assembly instructions to do basically this, where we say go back exactly to that line right there. Let's go ahead and test it to make sure there's not a mistake. Let's see. Okay. Don't think it likes having a label there as the last thing in the function, so let's just put another something there. There's 3 hellos. All right, there's one example. Let's look at one more example. So this is sum n, and the code's already there. So what this is supposed to do, the add n is supposed to add up the numbers 1 up to n. So we call add n 10. It should give 55 as the answer. And here's the structure of the code. So we start with a total, and what do we want to do? We want to add 1 plus 2 plus 3 and so on. Or it's just the same to say we want to add n, n minus 1, n minus 2 down to 1. So here we have the total. I'm going to add n. Okay, so first I add on n. I'm starting from this way. Then I subtract 1 from n. So I would have my n value now is 1 smaller. It's the previous thing in this list. As long as I haven't gotten down to 0, I go back and do it again. So there's one goto statement. So I add, I'm 1 smaller now with my value of n, add that onto the total, decrease again, so I keep going down this way with my value of n gets smaller and smaller, I keep adding it up, eventually I return it. Okay, so there's another example where we're using a goto instead of loops. So I'll put something in here about goto. Just because. So this is not something that you're going to be using in your C programs. That's not why we're doing this. It's just interesting. Okay, so note that loops ultimately get translated into assembly language and then into machine language. Both assembly and machine language convert loops into something similar to using goto. We'll put the goto here. What's the basic idea? You say exactly which line to go to next. That's the basic idea. Okay, so now we could use recursion that can do anything, loops can do anything, goto is really the same as loops, but note that goto considered harmful. At one point in time there was a great debate in programming about whether using gotos is good or not. In the end, it is bad, and you can come up with the reasons why you think it's bad. I would just say don't do it in this class, unless I specifically tell you to. You can look this up. Go ahead and look it up. Read the paper. It's kind of interesting. And I think that's really all I want to say about goto. Have fun with goto.